Hi, this is a lecture overview for 4.1, 4.3 applications. So we just talked about 4.1 and 4.3. Now we're going to take the applications from both those sections and tie them into one section. And so what I chose to do in this one is to take an application out of 4.1 and took an application out of 4.3 and showed you kind of what they look like and what the comparisons are. Not much comparisons, but because 4.1 is talking about linear functions and 4.3 is talking about quadratic functions. And on 4.1, this application that I chose to do is talking about a t-shirt company who are selling their t-shirts. And there's a supply and their demand. Now, and it's based on the price of the t-shirts that they're selling. So, as you know, if you set the price too high, nobody's going to buy it, so the demand goes low. Uh, but if you set the price too low, then the demand goes high. And so the supply and the demand needs to be about the same. Because if the supply is more than the demand, you have a lot of inventory left over. So you don't want the supply to be too much, and you don't want the demand too much, because if the demand is too much and you're not supplying enough to sell, so you got a lot of unhappy customers because you run out of items that you're trying to sell. So you want the supply and the demand to be about the same. And that's what we call the equilibrium. Okay, and so this supplier has their supply function to be negative 200 plus 50p. So if you set the, let's say you set the shirt about $6. So 6 times 50 is going to be 300, and then 300 minus 200 is 100. So you'll have a supply of 100 t-shirts. That's if you set the shirt at $6. You set it for $10, then you do 50 times 10, that's 500, and then 500 minus 200 is 300. So your supply goes up because your price went up. So, and demand. And what you want to do though is make sure the supply and the demand are the same, and that's what they want to know. What is the equilibrium price? So, what could we do to make the equilibrium price happen? In other words, what would have to happen to make the supply and demand to be the same? Yeah, you set the two functions equal to each other. So we have negative 200 plus 50p equals 1,000 minus 25p. And if you solve that equation, you should get an equation that solves for p, and that'll tell you what the price needs to be set at. And at that point, the supply and the demand will be exactly the same. And that's equilibrium. So add 25p to this side, and that's 75p. And add 200 to this side, and that is 1,200. Then you divide both sides by 75. Now, I did not do this problem before now, so I don't know what 1,200 divided by 75 is off the top of my head, but I can do a little bit of the calculation. Let's see. If I divide both top and bottom by 3, that's 400. Divide that by 3, that's 25. And I believe that would be 16 then. So, got lucky. So, looks like the price needs to be set at $16 a piece. So, each t-shirt needs to cost $16 in order for the supply and the demand to be equal. So, if you set the price at more than $16, then that means your demand goes down and your supply goes up. If you set it less than $16, let's say $15, then that means your demand goes up and your supply will go down. So like we said, we want to make them the same. So you need to set the price at exactly 16 bucks in order for everybody to be happy. No inventory left and no unhappy customers. Now, the second problem is 4.3 is about an application of maximizing and minimizing. Now, if you remember back in 4.3, we talked about parabolas and how parabolas go open up or down. When they open up, they have a minimum, and they down have a maximum. Well, that's important in applications here, because a lot of times they'll give you a formula or a situation that's a particular model that's based on a parabola. And based on that model, they want you to either minimize a function or maximize a function. In this particular case, we want to maximize a function. This is a company called John Deere. Everybody's heard of that one. They sell riding mowers among other things. They have a revenue function. Revenue functions are basically functions that determines what price you need to set the item at in order to make them out this amount of money. And it's different between a cost function. This is a revenue function. So revenue function is negative 1/2 p squared plus 1900 p. Now, if you don't read any further, you look at that function, you'll say, okay, negative 1/2 p squared, that parabola opens upside down because of the negative 1/2, which means it has a high point. And since it has a high point, it has a maximum. So if you read further into the problem, the question should ask something about a maximum. They're not going to ask you for a minimum because the graph continually goes downward. And if you read, sure enough, what price should we set to maximize the revenue? So we do that by the negative b over 2a that we learned back in the earlier 4.3. And then, so it's going to be negative 1900 over 2 times negative 1/2. And if you do the math, I think that's exactly 1900 because the 1/2s cancel with the 2 and the negatives cancel out as well. So the price that needs to be set, it needs to be $1,900. So they need to sell these riding mowers for $1,900 to make the most money, make the most revenue. So that's how it works. You're like, well, what if they sell the things for like 2,000, they should make more money, possibly, or not possibly. Because you got to remember, if they sell for more than $1,900, not as many people are going to buy them. If they sell for $2,500, would you be as likely to buy it as if it was $1,900? So they may not have as many customers. So, and if you sell it for less than $1,900, sure, there'd be more people buying them, but you're not making as much profit off of each one of them of how it costs to make the things. So there's a position, in this case $1,900, that will make you the most revenue. And then the second part of the problem is they want to know what that actual revenue is, how much actually is it. So here you just have to put 1900 back in. And I'm not going to do that one. But what I will tell you, you just put 1900 for here, and you will definitely need a calculator. So, and I will leave that up to you to do. So, and that's it.